term that is going to be used a lot for you this year and going forward is going to be slope. Did you talk much about slope last year? Do you know any idea what it is? What is it? Okay, it's a line. Give me some examples of what we would care about, what the slope is in real life.
If you're doing something with statistics.
Okay. Yeah, statistics, but how about just everyday life? Why would we care about the slope of something?
I feel like carrying furniture with like a slope. That's like difficult.
Yeah, I mean, stairs need to be at a certain slope or it's going to be hard to walk up them. Yes, there's an example. Stairs. Okay, rise over run. That's literally called risers when you build your own stairs. What else? What's a common winter activity? It's literally called the slopes, right? And why do you think that is? Right? They have different angles that you go down. Anybody snow ski? Yeah, you're not going to go on the Black Diamond to start, right? That's steeper, more of a slope. Roads have a slope. Central has a certain slope. Your driveway has a slope. Okay, a lot of different things. Now, what does that mean? On the left side here, I'll give you some generic definitions of it. If you have a line that goes uphill, okay, so a car is driving left to right, it goes uphill, that's always going to be a positive slope. The opposite of that, if you have a car that goes downhill, that will always be a negative slope. And two of them that are probably a little more confusing, the vertical and the horizontal line. One of those has a slope of 0 and one of them is undefined. Okay, what helps me remember, again, I think of skiing. If I am on a horizontal line, if my slope looks like this, am I going to move? No, so this is slope of 0. Whereas if you see a hill like this, you're in trouble, right? If it goes straight up and down, that is bad. So that is undefined. And that is true for every vertical line, that is true for every horizontal line, just so you don't get those confused. Again, just my analogy, whatever helps you remember those 4 things, because it's important to know the difference as we go. So the first example, and there are different ways to write different amounts of slope. That's what it's gearing you up for here. It says write some numbers that are equal to 15 over 12. What are some numbers that equal that? Well, I could certainly just write it as 15 over 12. I could actually take 15 divided by 12. If anybody has their calculator open, if you could give me that one, that would be great. I could write it as 1.25. I could reduce it, right? I could divide top and bottom by 3. I could write it as 5 over 4. I could write it as 1 1/4. I could double both those numbers and write 30 over 24. The point is, there's a lot of different ways to write the same number. Normally, we always reduce it, right? And it's only one possible answer for everybody. But those all mean the same thing. And you could list them forever. So we're going to look at these triangles on the next page. I'm going to do the first one for you and have you do the other ones. Triangle ABC, that's this triangle right here, the vertical side. Vertical means up and down. The vertical side is 3. Horizontal side is 4. Vertical over horizontal, it can be written as 3/4. Okay, why don't you finish the table there with those other 2 triangles? Alright, what do you got?
It's 6 and 8. It's 6 over 8.
Which can be reduced, right? Alright, last one. Adam?
1.5. Very close.
So 1.5 over 2. Now I could double both of those, right? And I could rewrite it as 3 over 4. Now the whole point is the slope is the same, right? Well, we can see that they're all on the same line. They all have the same slope. It's positive, notice, going uphill, left to right. The slope is 3/4. So on the next page, it says draw 2 lines with a slope of 3. All right. One other trick I'm going to tell you about slope that they failed to mention so far, but I think it's super helpful. Slope is rise, how far up and down it goes, over run, which is how far left and right it goes. Rise over run. So if I pick any dot, it doesn't matter where it is. If I want a slope of 3, that means I go up 3 for every one I go over. Okay. Slope of a roof is the same thing. Okay. It has different pitches. So this is a slope of 3. That means it goes up 3. In the span, it goes over 1. Up 3, over 1. Then when I connect them, I like to do 3 dots, make sure everything's lined up. If you don't, something is wrong in your counting. So there's one example of a slope of 3. So somewhere else on there, I'd like you to write a slope of 3, another one. And then it wants 2 lines of a slope of 1/2. So I'd like you to do both of those items. So you should have a total of 4 lines on there. One we drew together. Draw one more with a slope of 3 and 2 of them with a slope of 1/2. All right. Doesn't matter where you put it, slope of 3 should look very similar to this one. It says, what do you notice about the lines? What do you notice about your 2 lines with a slope of 3? Expand on, they're the same. Yes, they are parallel. Why? Because they're the same slope. Same slope, parallel. Both a slope of 3. Slope of 1/2. Again, pick any point you want. Rise over run. That means up 1 over 2. Up 1 over 2. Connect the dots. Pick another spot. Up 1 over 2, up 1 over 2. Again, I like 3 dots minimum to connect. And what do you notice about those two? Parallel. Now let's compare the two of them. How would you describe the difference between slope of 3 and slope of 1/2? They certainly look different. Othniel, what do you notice? What's the difference between slope of 3 and slope of 1/2? Wyatt? Which one do you want to go skiing on? Let's say you're a beginner, never skied before.
Where they going?
Parallel lines.
Well,
Straight up and down.
well, then it's like less steep.
Less steep, right? So what made it less steep?
The angle of that.
Yeah, the angle. So the smaller the number, remember, just like you're talking scale factor, bigger the number, the bigger the object. The bigger the number, the more steep it is. That's the point. Higher the number, more black diamond-esque if you're a skier. Right, slope of 10, even more. 20, even more. It's gonna keep getting steeper and steeper. As it gets smaller, right, 1/2, 1/4, 1/8, until it gets to 0 and it's completely flat. So bigger number, steeper. Smaller number, closer it is to 0, less steep. Flatter, however you wanna say that. That's the point. Keep that in mind as well. So knowing that, they list 6 different slopes there for us, and it has 5 graphs. So with what we just talked about, see if you can match them. And then there's going to be one that doesn't have a match that you have to draw. So go ahead and match those 6 slopes with those 5 lines, and then draw the missing one. I'll give you a few minutes here to do that. Give you about another minute or so, and then we're gonna go through them. All right. What do we got for A? Who wants to take that one? Zoe? Not Zoe. Gerhard. So which number goes with A? Here's your choices. Maybe I didn't explain the directions very well. Layton. 1. Okay. What do you have? Yeah. 3/2. So if you look, they have a little nice triangle here drawn for you. So it goes up 3 to the right 2. I mean, 1 is close, right? 3/2 is the same as 1.5. That's pretty close to 1. But they drew us this little triangle to help. Vertical is 3, left and right is 2. So 3/2 is the answer for that one. So that one's out. B, again, I'm going to use the triangle that they have drawn for us. Up and down is 2. 1, 2, 3, 4, 5, 6. So the slope is 2/6. Not an option. I don't see a 2/6, so of course I'm going to use 1/3 and reduce it. C, 1, 2, 3, 4, up 5. 1, 2, 3, 4, 5, right 5. 5/5. 1 is your slope. Now D does not have a triangle drawn. You can certainly do that. Find 2 points that are for sure on the line and draw your own triangle. Or just count. Up and down is 4. Left and right is 2. Two, 4/2, slope of 2. Yeah, a little steeper than the other one, right? More steep than this one. Same thing on this guy. Looks like 1/4. So that'd be 0.25. So the one that's missing is I gotta draw a slope of 1/2. Okay, well, you just drew 3 of them, I think, that were 1/2 on the previous page, so that shouldn't be too bad. Pick a point, up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2. You can go on forever. Connect them. There's the slope. Any questions on that? Again, apologize if my directions were not good. Good example on page 89. All of those triangles are going to have the same slope because they all follow the same line. Right? They all have the same slope. They all reduce to the same thing. And it doesn't have to always be a nice number. A nice fraction is perfectly fine. Those are just called slope triangles. All right, so your homework then, starting on page 90. Pretty well all on slope today. One review question looks like for number 4. 1 through 4 for Monday, please. 1 through 4.